Hi, my name is Janhavi Chaudhari. I am a third year E&TC student. Today, I am here to give a presentation on renewable energy mapping in Maharashtra, India using GIS. It is a research paper activity. The author of this research paper are Sampada Kulkarni and Ranjan Banjari. Now, I will start the presentation. This is the outline of the presentation. The first part is the introduction part. Energy is one of the most important input for the economical growth and human development. The sustainability of future energy system is for is critical for sustainable development. Renewable energy is useful energy that is collected from renewable sources which are available in nature such as sunlight, wind, rain, tide, waves. One of the first steps of this exploitation of an energy source is its estimation and mapping to identify the most sustainable area in terms of energy potential. To understand the current trend of the renewable energy, it is important to analyze the spatial variation of resources and their deployment. GIS. The full form of GIS is Geographical Information System. It is a system that creates, manage, analyze, and map all the type of data. The wind energy potential can be estimated by using GIS technology. The solar irradiation is estimated by CSV. The monthly wind energy production is estimated by using Weng bulb representation. Energy mapping in Maharashtra. Maharashtra is situated in the western part of India. It covers the entire Deccan area, which is about 1,19,000 square miles. There are 35 districts in Maharashtra. It is the largest power generation state in Maharashtra, with an installed capacity of 22,435 megawatt. Open domain quantum GIS is used to represent the spatial data. Proposed The next part is proposed methodology. District shape file of Maharashtra state is taken as the first input to QIS interfacing. This shape file may be created in C++ environment or may be directly downloaded. The shape file contains location attribute and area of these 35 districts. Data base is obtained from the current installed renewable power generation site with their rated power output, which is in megawatt, and location attribute. The meteorological station of wind and solar are identified and the corresponding data of instantaneous value of parameters like wind speed, wind density, well-being parameter, etc. and so, global solar radiation are obtained. Database of renewable power generation in Maharashtra. For wind, the number of meteorological stations are 7. Its estimated potential is 4.58 megawatt. Installed capacity is 2.01 and the number of installed power generation site is 31. For solar radiation, the number of meteorological stations are 3. For baggage cogeneration, number of installed power generation sites are 39. Its installed capacity is 0.35 and estimated potential is 1.25. For hydropower, number of installed power generation sites are 28. Its installed capacity is zero point 0.2 and the estimated potential is 7.5. Input parameter used in QGIS interface. The summary of the input parameter for district shape file, the information is 35 district location. For wind meteorology station, the information available is there are 7 stations. Solar meteorological station, there are total 7 stations. Wind installed sites, there are total 31 sites available. Baggage cogeneration installed sites, there are 39 sites which are located around sugar factories. Small hydropower installed sites, there are 28 sites. Renewable energy resource mapping. The distribution of wind power and solar insolation is estimated for the state. The wind power density is estimated using spatial interpolation technique, keyring interpolation. 7 stations are identified where actual measurement of wind power is done. These stations are at Lonavala, Malwan, Vijayadurg, Panchgani, Devgaon, Vangurla, and Chali, Chalkewadi. There are 31 wind power generation sites. The stations are represented by this symbol. The 30 and the installed wind power site are represented by a circle. Spatial interpolation of solar resource mapping. There are 3 meteorological stations identified that are in Pune, Mumbai, and Nagpur. Renewable installed capacity mapping. In the field of green energy, the major renewable energy source in Maharashtra are wind energy, small hydropower plants, and baggage cogeneration plants, with a small contribution of waste to the power plant and baggage. 31 sites of wind power generation, 39 sites of baggage cogeneration plant, and 28 sites of small hydropower plants are being identified. Conclusion. A framework is developed for mapping renewable energy resource using a open domain GIS and linking these with the database of the individual stations. Using this framework, it is possible to determine average wind and solar energy density in selected areas. This is illustrated for Maharashtra state in India. This method is simple and it would be useful in general or for engineer, architecture and solar system designer. Thank you.